Hi there. So yesterday I released BSV-ex version 2. This is a general purpose utility library for building Bitcoin applications with Elixir. It's version 2, it's a complete rewrite of the previous version. There's loads of new goodies in there. So I wanted to try and do some screencasts just to show some of the stuff that we can do with this code, particularly for people who might not be familiar with Elixir and haven't tried Elixir. I thought it might be helpful to kind of do a few screencasts. So we're going to give this a go, see how it goes. I'm going to start off with some real simple examples. To do this screencast, I'm going to use something called Livebook. This is a Elixir tool. It basically allows you to create live notebooks, and within those notebooks we can put Elixir code and evaluate that code within the notebook. So you can do some pretty funky stuff with this, and I think it might be quite a nice way to demonstrate some of my code, and then I can share the notebook with you so you can load up Livebook and play with the examples that I've created. So there's a few different ways of installing Livebook. Probably the easiest, if you don't have Elixir already installed, is to use Docker. Just a simple command, you can get your Livebook up and running, and then you're going. So in this notebook that I've created, we're going to create two contracts, and they're really simple contracts. First one is going to be a math puzzle, and we will unlock that contract by specifying two numbers that add up to a given total. And then we're going to create a hash puzzle that is unlocked by knowing the data that results in a given hash. So within our notebook, we're going to install the BSV library first of all. We must specify that it's version 2. If we evaluate that, that will install that code. We can see that's done, and now that the BSV library is available for us to use in the rest of this notebook. So the first puzzle we'll create is our math puzzle. We define a contract. It's just a module, and we use the BSV-contract behavior module, which is a behavior, and we implement that behavior by defining two functions, a locking script and an unlocking script. Both of those functions receive two arguments. The first is the contract itself, and the second is a map of arbitrary parameters that our contract expects. So if we have a look at this, we can see our locking script receives one parameter, which is our answer, and that's an integer. And our unlocking script receives two parameters, a and b, which are also both integers. So the unlocking script puts both of those parameters into the script. That's all it does. And our locking script adds those two numbers together. We then put our answer into the script, and the script is then verifying that those two numbers added together equals the answer that we've given in our locking script. Now, it must be said, this isn't a very secure contract. Your average 5-year-old hacker will comfortably be able to solve this problem and spend your bitcoins. But as an example of how this stuff works, I think it's quite a neat and simple example. So BSV-ex also features a script interpreter, and this allows us to simulate our contract. So by using the contract.simulate function, we can pass our contract module as the first argument, and then we pass a map of parameters for our locking script, and then another map of parameters for our unlocking script. If we evaluate this code, we can see that is currently returning true, because we've passed in the values 10 and 15, and we're expecting them to result in 25, which of course they do. If we were to change one of these values, let's say add 10 and 10 together, of course it doesn't equal 25, so we would expect that to evaluate as false, which it does. So our next contract is the hash puzzle. Now conceptually this is a little bit similar to the math puzzle, but because your average 5-year-old probably can't compute SHA-256 hashes in their head, it's hopefully going to be a little more secure than our previous example. So if you take a look at the unlocking script, you can see we've passed our raw data, our text, into that function, and notice that we actually push a hash of that text into the script rather than the raw data itself. And then if we look at the locking script, that data, which is already hashed, is going to be hashed again and compared with our answer. So actually we need our answer to be a double SHA-256 hash for this to verify, which we can do using the function here, SHA-256, SHA-256. If we evaluate that, we can see that our simulator is verifying our contract. If I was to change an element of this, let's change our raw text, add in a few characters, reevaluate it, and this is no longer a valid contract. So finally, let's build a transaction. We can use our contract modules in the TX builder by calling the lock function on our contract modules. We can lock a given number of satoshis using the parameters that we specify. So hopefully you can see what is going on there. If we evaluate this code, this is going to give us a raw transaction. Now of course there's no inputs to this transaction, so it's not spendable, but if we copy that, we can head over to what's on chain, go to the transaction decoder tool, and let's have a look. We decode that. We can see we have a transaction with two outputs. The first has our math puzzle locking script, and the second our hash puzzle locking script. So that is a real simple introduction to the tools I've been creating. I'm quite excited by the approach I've got here with how we define and describe these contracts. Because these functions here, they're all just Elixir, we can use this as a way of just creating functions that act as macros for creating more complex script operations. So I've got a few more tricks up my sleeve that I want to show you in future screencasts, but I thought I'd start off with this real simple example. In the show notes and on the article for this, you can find a button which will allow you to install this Livebook in your instance of Livebook. So please give that a try. You don't need to install Elixir or know anything about Elixir. You can just play around with this and get to grips with it.